So 75% should lie within how many standard deviations? 2. So we're going to take 100 and we're going to subtract, well, let's just make a little, make a little thing down here. 100, 2 standard deviations will get us to 15, 15, 130, and 170. Good? If we go 3 standard deviations, so this is the first part, 70 to 130. If we go 3 standard deviations, we get to 145, and we get back to 55. Good? So within 3 standard deviations, 55 and 145. Questions? You guys need to check with your neighbors? Okay. Here it is prettier. Yes? Yes. Right, so the coefficient of variation above that, the coefficient of variation is used to compare variations or standard deviations, either one, of samples with different means. Normal distributions. You guys remember last week we talked about, or a couple weeks ago we talked about histograms and bell curves, right? They start off low, they kind of max out at the top, where most of the data is, and they kind of droop off at the end, so they make this kind of bell-shaped curve. It's roughly symmetric. So now we're going to talk about normal. If your data is normal, a lot of the data we're going to be working with in this class is going to be normal. Someone said, well, how do I know if it's normal? There is a whole section in your textbook dedicated to determining whether data is normally distributed or not. It's not required. I don't emphasize that. Every instructor emphasizes different things. So I kind of pushed you guys more on the at least one and being the complement of none. And so I don't push that. So how you guys will know if data is normally distributed is, I will say in the problem, assume the data is normally distributed. That's how you know it's normally distributed. So we'll kind of go through some of the rules, but that's kind of the main thing. Why is it not working? The empirical rule. So if your data is approximately normally distributed, then you can do better than Chebyshev's. Chebyshev's says within 2 standard deviations, at least 70%, right? So Chebyshev's says 70% to 100% will fall within 2 standard deviations. That's a pretty big range, at least 70%. Does everyone understand the idea of at least 70%? That if someone says you have to be at least this tall, does that mean you have to be exactly this tall to ride that ride? No. You can be taller, right? So at least 70% means 70% or more. So Chebyshev's says 70% to 100%. If it's approximately normal, we can say about 95%. So instead of between 70 to 100, it's about 95%. Within 3 standard deviations, Chebyshev says about 89% to 100%. This one says about 99.7%. So it's a lot more specific. It gives you kind of a right around this area, right around 99.7%. Might be off by 1% or 2, but right in that neighborhood. And then it also talks about 1 standard deviation, which Chebyshev doesn't cover, which it says about approximately 68%, right around 68%, fall within 1 standard deviation of the mean. So here's my mean. I go 1 standard deviation this way. I go 1 standard deviation that way. Between these 2 numbers, about 68% of my data lies between those 2 numbers. Everybody okay with that part? This is what we call the empirical rule. That's also known as the 68, 95, 99.7 rule, because 68% within 1 standard deviation, 95 within 2, and 99.7% within 3. Here it is visually. So here's my mean, guys. If I go one standard deviation this way and one standard deviation that way, then about 68% of my data is going to lie between these two numbers. If I go two standard deviations this way and two this way, then about 95% of my data is going to lie between these two numbers. And if I go three standard deviations this way and three this way, then about 99.7% of my data is going to lie between these two numbers. That's what Chebyshev says. Oh, sorry, not Chebyshev. That's what the empirical rule says. But it only applies to normal data. Chebyshev's applies to any data. The empirical rule, your data has to be approximately normal. So let's take a look at this example. Why don't you guys try to figure out the very last thing on this page? I'll give you guys a couple minutes to figure out those ones. I thought you about 30 seconds.
Yes, because it's the sentence, right?
From there, from where you know how much to get in the data. So
It's on the homework.
oh yeah. So, I know it's wrong, but I don't know. That's making
Chebyshev is always true. No matter what the data is.
It's 4. Let's go then. Let's go. I don't know.
Do a line with it. Yeah. So I wrote it out like this.
All right, what's my mean, guys?
So those are the right
Mean is 100, standard deviation is 15. So we're going to start with 100, and we're going to jump. 15, that gets us to, 85, 115. So 68 will score between 85 and 115. We jump 2. It gets us to 130, 70. Right? Yes? Write these down. Write them in squares. And then 3 standard deviations, 145 and 55. Good? All right. Now, put these away. Get out your the handout that we took out, that we started today, that you just got today. We're going to start this now. All right. So now we're going to talk about the last thing, measures of relative standing and box plots. I think it's 3.3 actually, I'm not sure.
3.3 man.
Yeah. So we're going to kind of start in with these. Z values. Do you guys remember population mean, population standard deviation, sample mean, sample standard deviation? Talk to your neighbors and figure out what the symbols are. 15 seconds. We'll discuss them. you're not talking to your neighbor, I'll call you.
So it's 5, right? Sorry? So it's 5. Wait, what? Oh, I haven't decided.
Rolla, what's my population mean?
So, population is like
Yep, population mean.
the population distributed.
Remember it?
An example is that just take 5 people.
You, good job. You. And then a population standard deviation is the other Greek letter. What's that one, guys? Sigma. Great. And then, oh, hold on. Let me call on somebody else. A sample mean. I don't know. Armida? Sample mean? You can take a help from your friend. That's fine. Help your friend. Nope. Close.
X bar.
X bar. Sample standard deviation, anyone? S. S. Good. All right, so which ones are statistics and which ones are parameters? Talk to your neighbors, 15 seconds. Statistics, I got something.
Parameters or population.
All right, which ones are parameters, guys? Yeah, these guys are parameters.
Oh, wait, no.
And sample, those are the statistics. So mu and sigma are parameters. People freak out when they see the words parameters. Mu, things that are for the population, mu and sigma, those are parameters. Statistics are our sample mean and our S. This class is called statistics. So typically we'll be dealing with finding X bars and finding S's. All right. Z values. So here's an example. 55 plus or minus 10. So that means kind of in general, that means that the mean is 55, the standard deviation is 10. What's my mean? 55. Everybody see that? Everybody, can you guys read that? How far is 60 from the mean? 5. It's 5 away. How many standard deviations is 5? Half. A standard deviation is 10. Do you guys see that? So if a standard deviation is 10, then 5 is half of a standard deviation.
So would you write that as 0.5 or just 1/2?
Either
Right
one.
there.
So, and how do you find it? I take my 5, I divide by what a standard deviation is. So it's 1/2 or 0.5. Either one is fine. If you think about it, if I have 24 inches, if something's 24 inches long, I want to know how long it is in feet. What would I do? How many feet how many inches in a foot? 12. So if I have something that's 24 inches long, I want to know how many feet it is. What do? I divide by 12 because there's 12 inches in a foot. So if there's 10 whatevers in a standard deviation, and I want to know how many standard deviations is, I should divide by 10. Divide by however many is in a standard deviation. How about 40? How far is 40 from the mean? 3 people know this? What's my mean?
55.
How far is 40 from 55? 15. Is it above the mean or below the mean?
Below.
Below, so it should be negative. Everybody on board with that part? I want to know how many standard deviations that is, so I take negative 15 and I divide by a standard deviation. So it's negative 1.5 standard deviations from the mean. So its z-score is negative 1.5. A z-score represents the number of standard deviations a value is above or below the mean. It's a measure of how far from the mean it is. Yes?
So for the 60, does it matter that we didn't put like +5 because I know that
Nope.
that's obviously
If it's a positive, you don't have to put a symbol. It's understood that it's positive. But it's negative, you need to put a negative in front of it.
Is 0.5 the z-score for 60?
Yeah. So 0.5 is the z-score. So here, the z-score is 0.5, and here the z-score is negative 1.5. It's the number, this 40 is 1.5 standard deviations below the mean, so its z-score is negative 1.5. 60 is 0.5 standard deviations above the mean, so its z-score is 0.5. All right, everyone take a deep breath. Let it out. I need you guys to focus for just a minute, because this is important. That's why I wrote it down again. So this part right here, we're going to read this together as a group. Ready, set, go.
A z-score represents the number of standard deviations and values above or below the mean.
Why am I making you read this? Because it's super freaking important. Z-scores are going to be important all the way from here through chapter 9. They are really, really important. You need to know what they are, what they stand for. People forget them all the time. So it will literally be one point on the exam will be to finish the sentence a z-score represents, and you have to finish it like I said in class. This way, not some other way that's valid. This way.
Word by word?
Pretty close, yeah. Yes.
Can it be the shorter part that's in parentheses, or does it have to be
Nope.
circled?
That's the upper part. You could say, we'll talk about that later. We'll talk about the variations later. But that needs to be essentially what you have in there. Please, so in other words, here's the mean. I'm this far away from the mean. How far is that in standard deviations? That's my z-score. Please note for any specific why am I reading? Sure, go ahead.
For any one specific variable, each value has exactly one z-score, and each z-score corresponds to exactly one value. Example, for average team height of 66 inches and standard deviation of 4 inches, the value of 64 inches has a z-score of negative 0.5, and also the z-score of negative 0.5 has a value of 64 inches.
Right, so those are the same, they represent the same spot, the same thing. So if I were to draw a little thing here, here's my 66 inches, my mean, and then over here is 64 inches. This value has a z-score of 0.5. Z-score, and this is inches, my x's. Also, negative, should be negative. So the x value of 64 inches has a z-score of negative 0.5. Also, the z-score of negative 0.5 has only one value, 64 inches. Those kind of match up. What's the z-score for this guy here? 0. Yeah, how far is 66 from the mean? 0. It's itself, right? Make sense? Okay. How do we find the z-score? You take the value, you figure out how far is it away from the mean, you subtract the mean. That way, if it's positive, it should be, if it's above the mean, it should be positive. If it's below the mean, it should be negative. And then, you divide by a standard deviation, so you have it in standard deviations, not in inches or whatever you have. This is how it looks like as a formula. This is on your notes on the first page. You should also write this next to it. For a sample, the z-score is going to be x minus x bar divided by s. That's for a sample. Well, I mean, yeah, means have mu's and sigmas. Populations have mu's and sigmas. Samples have x bars and s's. I'm getting tired too. Yeah, populations have mu's and sigmas. Samples have x bars and s's. So for a sample, you use this. population versus a sample. Let's interpret them a little bit. So remember, our typical values are within 2 standard deviations of the mean. So here's my mean. Go 2 standard deviations this way, 2 standard deviations that way. Those are my usual values. So it means that a z-score that's less than -2 or greater than greater than 2 would be unusual. The usual values will be within 2 standard deviations. So the usual values will have a z-score between -2 and +2. The unusual ones will have a z-score less than -2 or greater than +2. That just falls straight from like empirical rule. And usual, unusual. Darren, good read.
Heights of women on a soccer team have a bell-shaped normal distribution with a mean of 164 centimeters and a standard deviation of 7 centimeters. And Candace has a height of 178 centimeters. Is she above or below the mean?
Is she above or below the mean, guys?
Above,
Above. How far above?
14 centimeters.
14 centimeters. Good? How many standard deviations is that? Your z-score, 14 centimeters, divided by, what's my standard deviation? 7 centimeters. So your z-score is 2. How about Jenny? So I'm going to use the kind of the formula here. Jenny, her z-score is, her height is 169. And if you figure out how far she is from the mean, what's the mean? What's the mean? 164. And then, so that will tell me how far she is, right? This tells me how far she is from the mean. But I need to divide by standard deviation, so I have it in standard deviation. So standard deviation is 7 centimeters. Everybody find that?
Yes, it's 0.714.
Great. Everyone take a minute and do Laura's.
Is z-score 3 sig figs?
3 sig figs is good. Actually, 2 decimal places is probably fine, but I'm good with either. Everybody find Laura's.
Yeah, I can put it in over
You can't do it here. You're going to have a hard time doing it on your own on the exam. When you're done, check with your neighbors. Make sure you have the same answers.
So this one, this one. Can you get that? But then what? But then negative. So it's a negative, right? Yes.
Okay, so you guys should have this 1.7, negative 1.7. I'll see this 1.71. That's fine. All right, so you guys find Steve's. Take a look at Steve's. You're quite behind.
So she has a height of 178 and then the mean is 164. So it's 178 above the yeah.
So how tall is Steve?
63.7.
What's the mean?
67.4.
So subtract those. And then divide by standard deviation. What's the standard deviation, guys?
2.6.
2.6. If you do that, what do you get?
Negative 1.42.
Negative 1.42. Is he unusual or not unusual?
Not.
He's not unusual. He's within 2 standard deviations. So everybody remember that part? Usual values are within 2, so down to -2 and up to +2. Those are the normal values. Okay. Last thing we're going to cover today is percentiles. These are measures of location. There are 99 of them, labeled P1, P2, P3, all up to P99. They divide a set into roughly 100 different groups, with each group about, being about 1% of the population, or the values of the group. So the idea of a percentile is you figure out, a percentile tells you, bless you, what percent of people you beat. So you take wherever you are, you count the number of people below you that are less than you. How many of them are there that have a score less than you? And then you find out what percentage, what fraction of that is of the whole. So you figure out how many are less than you out of the total, right? Find that relative frequency and then change it to a percent. So multiply it by 100%. Let me give you an example.
So do you do all of these and add them?
You guys look up and focus for a minute. I need all eyes up here. So I want to find the percentile. This is yours, not mine. Cookie with 23 chips. So here's the last 23 right there. I'm going to count how many came before it. There are 10 that are less than it. 10 out of how many? 10 out of 40. And then change that into a percentile. Multiplying by 100%. That ends up being 25%. So this is the 25th percentile. Make sense? Good? Yes, you guys go ahead and work on your example. What's your question?
So you had said that that was the last 23, so were we supposed to do it from the last 23 or the first 23?
The last one.
That's,
So how many are less than 23? You can't go with this one because 23 is now less than 23.
Oh,
Is that, you guys see what I'm saying? How many are less than 23?
starting from 23.
Yeah. So you guys try to stay focused because the longer I have to wait for people, then the longer the class takes, right?